All right, y'all, it's time to start getting into some actual math. And before we do that, there's a couple of things that I need you to spend a little bit of time reviewing. We're not going to go over it in the video. We're not going to spend a lot of time in class. So the first thing that you need to make sure you understand is this quick review on fractions. So pause the video, read through this screen. If there's something that you need to practice it. If there's something you need to take notes on, because you feel like you'll have a hard time remembering, take the time to do that. But the stuff on this front screen here are things that you need to understand for the future. But we're not going to spend class time on it because it's all review information. So pause the video, take notes on what you need to. The second thing that I need you to spend a little bit of time reading through on your own is this problem-solving outline. We're not going to spend a lot of time on the video talking about problem solving. We'll do a little bit of this in the classroom, but go ahead, pause the video and read through these 3 steps that are kind of designed to help you work through problems that aren't just simple, here's a few numbers, add them together. It's designed to kind of help you with problem solving. And like I said, we'll work on it in class a little bit, but there's going to be a few questions on the homework tonight that you're going to want to be able to answer. So go ahead, hit pause, and just read through these 3 steps real quick, and then resume the video when you're done. All right, now into the actual math. We're going to start with talking about units, because in the real world, you don't see a lot of things out there, a lot of problems asking you 30 times 12,000. That's not a problem that you're going to have to do. Most of the math that you're going to do in the real world has context to it. So in other words, we're not just talking about the number, we're talking about what the number represents. So our first example here, part A says that you are buying 30 acres of farmland at a price of $12,000 per acre. What's the total cost? So you're trying to figure out what it's going to cost to buy this farmland. Now the units are the description of what the number is. And I don't think we need to spend a lot of time on that, but it's something to review if you need to. So in this case, we're talking about buying 30 acres of farmland. So that right there, the acres is my unit, and the price is $12,000 per acre. So again, my unit is dollars. I'm talking about money. Now, when we're dealing with, well, really pretty much everything we do today, we're going to be looking at comparisons. And there's a couple of different ways that you can do most of these problems. And I'm going to show you how to do a lot of it with proportions because they work all of the time. The book has another method. So if you get stuck on a math problem doing the homework, up at the top, there's a button that says Get Help. If you click on that, there's some options to show you an example, or there's options to let you look at the textbook. Now, the way that it's going to show you in the examples and in the textbook is a little bit different than what I'm going to show you, because I want you to see 2 different ways of doing these problems. For some of you, one is going to be easier than the other. So we're starting with problem A up here, that you're buying 30 acres and the cost is $12,000 per acre. Now, some of you really quick can say, well, I just take the number of acres that I want and I'm going to times that by the price. And that's going to come out to, what, 3 times 12, that's 36, but we've got a bunch of zeros, so $360,000. And we're going to make sure to include our units there. But not recognizing that, what we're doing is we're comparing. We're comparing the number of acres to the price, to the cost. And really, to do this problem, if you don't recognize simply to multiply them together, you can set up a proportion. I know that I want to buy 30 acres, so I'm going to put that on top, 30 acres, but I don't know the cost. That goes on bottom. I don't know how much money I'm going to need, but I do know that 1 acre is going to cost me $12,000. So because acres are on top, I make sure to put the acre on top, and money's on the bottom, so I make sure to put the money on the bottom. And I'm looking for this unknown value. So you can cross multiply and divide by what's left. So I can do 30 times 12,000 and divide by 1, and that's going to equal my value down here, my $360,000. Okay. Again, the book, the help button is going to show you another way to do that. One hint to look for is this per right here. Remember, per means a division line. So when it says 12,000 per acre, that tells you $12,000 per 1 acre. And it doesn't matter if the money's on top or on bottom as long as you keep it consistent. Okay. The second example here says a car travels 25 miles every half hour. How fast is it going? So it's telling me that I'm going 25 miles every half hour. And what it wants is my speed. And again, some of you are going to recognize, well, if I go 25 miles in a half hour, that means that I'm going to go 50 miles in 1 hour. So I'm going to go 50 miles per hour. Again, if you don't recognize that, you can do a comparison. You can do a proportion. 25 miles on top in 1/2 hour is equal to how many miles if I'm going for 1 hour? And you can cross multiply, divide by the piece that's left. 25 times 1 is 25. Divided by 1/2 is 50. And that'll give you your unknown value. Okay. So we're going to use that as an example here. We're going to use that proportion as a method to do a bunch of problems today. There's some keywords up here. If you're struggling with the problems, you can refer to these keywords if you need to. Remember, per usually means division, like miles per hour means miles on top, hours on bottom. Of or a hyphen usually means multiplication, and square and cubes, you're pretty comfortable with those. So let's look at some more examples. Find the area of a room. So if I give you a room here, and let's say that this length is 12 and this length is 9, those numbers don't really mean anything. If this was an actual room, they would have a unit with them. So 12 feet and 9 feet. And I want to find the area of that room. Now, most of you know to find the area of a rectangle, I'm going to take the 9 and multiply it by the 12. And so you're going to tell me, well, the answer is 108. Well, we're not dealing with the theoretical. We're dealing with the real world. So I can't just do 9 times 12. I have to do 9 feet multiplied by 12 feet. And that's going to give me an answer. Remember, you still multiply the numbers. It's still 108. That didn't change. But we also have feet multiplied by feet. So my 108 is going to be 108 feet squared because I'm multiplying 2 feet together. Same idea with the volume of a box. We know that the volume is the length times the height times the width. And 10 times 6 is 60 times 4, that's 240. But we need context. It's actually 10 inches multiplied by 6 inches multiplied by 4 inches. So again, the number is going to stay the same. That's still going to be 240. But this time I'm taking an inch times an inch times an inch. So that's inches cubed. Okay. We have to multiply our units together. And sometimes we have to actually divide them, which leads to canceling out. And we'll get to that here in a little bit. Another example, a utility bill will state electricity usage in units of kilowatt-hours. That hyphen means multiplication. So if a movie set is using 0.5 kilowatt light bulbs for 6 hours, how much energy does it use? So it's asking for energy, which is kilowatt-hours. Kilowatt-hours is how you read that. So I take my kilowatts, 0.5 kilowatts, and I'm going to multiply that by my hours, by 6 hours. So 0.5 times 6, that's 3. And kilowatts times hours is kilowatt hours, is how you would read that. So your answer would be 3 kilowatt hours. Okay, moving on. Identifying units. A lot of times in these problems, you may not recognize what the units are. We're not going to spend a lot of time here because for the most part at this point, you guys are pretty good at doing that. But example A says the price that you paid for gasoline. So what would be the units involved? It's found by dividing the total cost. So I take the cost, which is dollars, by the number of gallons. So I'm going to divide that by gallons. So that would be my unit. Dollars on top, gallons on bottom. And the way that we would say that in words is dollars per gallon is how you would read that. The area of a circle, you use the formula pi r squared. The radius is measured in centimeters. So r is centimeters and pi doesn't have units. So this is pi times r centimeters times r centimeters, which gives us pi times r squared. And my units are the centimeters squared. So you would write that centimeter squared. Volume found by multiplying an area measured in acres by a depth measured in feet. So I'm taking acres and I'm multiplying that by feet. And that's actually called acre feet. That's a unit. You're not going to see that one very often. It can be a little bit confusing in the real world, but it does have its uses when you're dealing with depths of areas of land and different objects like that. So acre feet would be your units there. All right, so using units to find a pathway. Now, again, the textbook and the examples are going to show you one method of doing this, and I want to show you another one. So the question is, how many crates do you need to hold 2,000 apples if each crate holds 40 apples? So we're trying to figure out how many crates. So my answer is going to be crates. That's what I'm looking for. I don't know how many crates, but I know that I need the number of crates that will hold 2,000 apples. So I'm going to put that on the bottom. Crates on the top, how many crates, X crates, are going to hold 2,000 apples? And it tells me that one crate will hold 40 apples. So I'm just comparing the number of crates that I need for the number of apples that I need. And I'm looking for the piece that I don't know. So I can cross multiply 2,000 times 1 and then divide by 40. And that will tell me how many crates that I need for those apples. Now, some of you are going to be able to read this problem and just recognize, oh, I divide this number of apples by this number of apples. Great. If you can recognize that right off the bat, more power to you. If you still are struggling with the problem, the book will give you another method of doing that as well. It involves writing out the problem a little bit different. And again, we're not going to focus on that on here on the video. That's something that you can get from the notes there. So unit conversions. This is something you've been doing for a long time. So hopefully you can recall some of what you learned in the past. But let's say I want to change inches to feet. Again, the math in this class is all about real world stuff. And sometimes you're going to have to do that. You're going to have to change inches to feet or seconds to minutes or cups to ounces. So it wants me to convert a length of 102 inches. It wants me to change that to feet. So what I'm comparing is inches to feet. And I know, if I think back to what I've learned in the past, that there are 12 inches in 1 foot, in 1 feet. But I don't want 12 inches. It tells me that I need 102 inches. So on top, I'm going to put 102 inches because that's on top over here. And on the bottom is what I don't know. I'm looking for X number of feet. So again, I can cross multiply. 102 times 1 is 102, and then I can divide that by 12 inches, which is going to give me my x value right here, which should come out to be, what, 8.5 feet would be my answer. Okay, so that's one way to do it. The proportion, I think, is the easiest with these conversions. Again, the book is going to show you something like I have 102 inches, but I want to change it to feet. So I want my answer to end up having feet in it. So I need to get rid of inches. And I do that by multiplying 1 foot on top to 12 inches on the bottom, because then my inches cancel out and I'm left with feet. Read through the examples. That might help you. I prefer the proportions if I can't recognize what to do. And again, some of you are going to recognize, oh, I just have to divide 102 inches by 12. Great. Again, more power to you there. Converting seconds to minutes. So I want to change 3,000 seconds into a certain number of minutes. So I'm going from seconds to minutes. Now I know that there are 60 seconds in 1 minute. And it tells me that I want to find how many minutes for 3,000 seconds. And I'm looking for my minutes. So that goes on the bottom with minutes. So again, cross multiply, divide by 60. 3,000 times 1 is 3,000. Divided by 60 is going to be what? 50? So 3,000 seconds is going to be 50 minutes. Okay. Again, the book is going to show you to take 3,000 seconds and times that by, we're wanting to get rid of the seconds, so that needs to go on the bottom. And the minutes are going to go on the top because I want my answer to be in minutes. Again, it's another method. It's valid. It works. I prefer the proportions, which are sometimes easier than others. In this last example, use a chain of conversion. So I'm not just converting one thing. I'm converting more than one time. I'm going from seconds to days. So it wants to know how many seconds are in 1 day. And this one, it might actually be easier to use the book's method, because if I start with days, because I want to end up with seconds. So I'm going to start with 1 day. And in the end, I want to know how many seconds. So I got to get rid of 1 day. I've got to convert day into seconds. Well, I know that I can convert days into hours pretty easily, because I can convert 1 day into 24 hours by multiplying by 24. Because 24 hours represents 1 day. So when I multiply this, the days cancel out. 1 divided by 1 is 1, and I'm left with 24. Well, now I need to turn the 24 hours into minutes. So I want to be left with minutes on top. And I know that there is 60 minutes in 1 hour. So again, my hours cancel. 24 over 1, the 1 cancels because it's on the bottom. It goes away. 24 times 60 is going to be, I don't know, what is that? 24 times 60 is going to be 1,440. So I'm left with 1,440. My hours canceled, so I'm left with minutes. Now I want to change my minutes into seconds. So I need to multiply by something with seconds on top. And I know that there's 60 seconds in 1 minute. So again, those units cancel. And I'm just left with taking 1,440 and timesing that by 60. So I take my 1,440 and I'm going to times that by another 60. And I get 86,400. So my answer is 86,400, and I'm left with seconds, which is what I wanted. How many seconds are there in 1 day? 86,400. So this one you can do with proportions. You can go from 1 day to hours and figure out how many that is, and then go from hours to minutes. Or some of you are going to be able to just say, well, if I start with the number of hours in a day and times that by the number of minutes and times that by the number of seconds, I'm going to end up where I want. So let's try some, well, I guess there's a little bit of review here. If you need to review decimals, go for it. If you just pause the video, look this over. If there's something that you don't remember, something you don't understand, maybe add that to your notes, but we're not going to spend time in the video reviewing fractions and decimals to fractions. What we want to do is look at units raised to powers, okay? So suppose we want to know the number of square feet in a square yard. So I want to know how many square feet are in a square yard. Well, I don't know off the top of my head. I do know that there are 3 feet in 1 yard, but I don't want feet, I want feet squared. And I don't want yards, I want yards squared. So if I take the top and the bottom, and if I square them both, then the 3 gets squared, 9, and the feet get squared, and that becomes 9 feet squared on top. And the 1 gets squared, which is just 1, and the yards get squared, which is yard squared. So there are 9 square feet in 1 square yard. That's one way to convert it. You can also say, well, I'm looking at yards squared, which is number of yards multiplied by number of yards. And a yard is 3 feet. So if I times 3 feet by 3 feet, 3 times 3 is 9. Feet times feet is feet squared. So I can convert it that way as well. Either way, you're just kind of playing with the powers of the units. Okay, so if you want to carpet a room that measures 10 feet by 10 feet, that makes an area of 120 square feet. So I have 120 feet squared. That's my area. But carpet is usually sold by the square yard. So I want to know how many square yards go with my square feet. So I'm going to put that on the bottom. I'm going to compare feet to yards. Well, I don't know this answer, but I do know I found it up here. I know that there are 9 square feet in 1 square yard. So I can put the 9 on the top and the 1 on the bottom, and now I just have a simple proportion. I can cross multiply these two and divide by the one that's left. So 120 times 1 divided by 9 is going to give me a number of yards. So let's do 120 times 1 is just going to give me 120. And then I'm going to divide that by 9. And it gives me 13.33333, which I would be comfortable rounding that to 13.3. And my units are yards squared. Okay. How about cubic units? You're preparing a vegetable garden. It's 40 feet long, 16 feet wide, and you need to fill it a foot deep. And it wants to know how many cubic yards is that. So I've got 40 feet multiplied by 16 feet multiplied by 1 foot. So when I multiply that, 40 times 16, I don't have that one memorized. 40 times 16, which is going to be 640. So the numbers multiply to 640. Feet times feet times feet is feet cubed. But I don't want feet cubed. I need yards cubed. And I don't know what that is. But again, I know from up here, I know that there is 3 feet in 1 yard. But I want cubed yards. So I'm going to cube everything. So 3 cubed, 3 to the 3rd power is 27. Feet cubed is feet cubed. And 1 cubed is 1. And yards cubed is yards cubed. So on the other side of my proportion, I need to put my feet on top. So 27 feet cubed over 1 yard cubed. And I can cross multiply and divide. So I'm going to do 640 feet cubed divided by 27. So 640 divided by 27. And that's going to give me 23.7 is a good place to round that one. So 23.7 yards cubed or cubic yards. Okay. Now I know our video is running a little bit long. This is a lot of examples, a lot of things to work through. So the homework for this one we'll probably just do in class tomorrow, since this video is getting up there a little bit. I think we're at about 26 minutes almost. So the last conversion that I want to look at is price conversion, which again is really easy to do with proportions. So it gives us some exchange rates up here. It says that a British pound, there's 1.221 pounds for every $1. So these are all compared to $1 US. Okay. And on this side, this is the foreign money. So this would be 0.8191 pounds per $1. All right. So it says at a French department store, the price for a pair of jeans is 85 euros. So I'm going to pay 85 euros. What is the price in US dollars? So 85 euros in US dollars, I don't know. But I do know if I find euros up here, which is here, euros go on top, and there's 1.058 euros for every $1. So let's cross multiply and divide by this number to find out my missing piece of the proportion. So 85 times 1 is 85, but I've got to divide by 1.058. So I'm going to do 85 divided by 1.058, and I get $80. Remember, this is money, and 34 cents. So this value would be $80.34. And we're dealing with money, so we might have maybe should have rounded this because there's stuff after the penny. Maybe we should have rounded that up to $80.35. But on the homework on the test, I'm assuming it's going to take either of those is the correct answer. Okay. You're on a holiday in Mexico and you need cash. How many pesos can you buy with $100? So we're comparing pesos to dollars. And I know from my chart up here, this is how many pesos go with $1. So on top, I can put 0.04574 pesos, and that's $1. But I don't want $1. I want $100 worth of pesos. So my X is on top because I'm looking for pesos. Dollars are on bottom. So we're going to cross multiply and divide. So I'm going to take 100 and times it by 0.04574, which really is going to just move that. Oh, whoops, I went backwards. See, we got to be careful with our conversions. I'm like, wait a minute, that doesn't sound right. I'm comparing the number of pesos for $1. So this is the number of pesos that matches $1 American dollar. So I've got to do 21.86 on the top. 21.86 pesos is $1. So 21.86 times 100 just means I move my decimal twice. So 2,186 pesos is what you could buy with your $100. All right. So the homework, you are more than welcome to give it a try at home. But again, this was a long video, so I'm okay if you bring it to class. We'll work on it together and practice some of these different methods of solving the problems. But the homework that this goes with is homework 2A. And it's not a very long one. I think there's 10, 12 questions on there is all. So take a look, see what you can do on your own. Otherwise, we'll work on it in class next time.